In this video, we're going to look at solving exponential equations using logarithms. Specifically, we're going to use logarithms to solve exponential equations with non-compatible bases, and we'll also look at how to solve exponential equations which are quadratic in form. Let's start by looking at the example where we're asked to solve the equation 5 to the x plus 2 power equals 4 to the x power. In this case, our bases of the exponentials on each side of our equation are 5 and 4, and these numbers are not compatible with each other. We're not going to easily be able to write one of them as a power of the other, or to write both of them as powers of the same number. So using the one-to-one property of exponential functions is not going to be helpful here. What we are going to be able to do is to apply logarithms to move those exponents down in front as coefficients. So in this case, what we can do is take the natural log of both sides. And so we know that the natural log of 5 to the x plus 2 will equal natural log of 4 to the x. And then we can use the power rule for logarithms to bring down those exponents. So on the left side, we're going to get the exponent x plus 2 multiplied by the natural log of 5. And on the right side, we're going to get x times the natural log of 4. Now, since there are x's on both sides of the equations, we really don't have much of a choice here, but to go ahead and distribute the natural log of 5 on the left side. So the left side will become x times the natural log of 5 plus 2 times the natural log of 5. And the right side will remain x natural log of 4. We now see that we have two terms here with an x in them and one term without. And so the easiest way to deal with this is to move all of the x terms on one side. In this case, I might move them over to the right side of this equation. And so what we're left with on the left side is just 2 natural log 5. And on the right, we have x natural log 4 minus x natural log 5. We can then factor out an x from the right-hand side. And in order to solve for x, we can divide both sides by the natural log of 4 minus the natural log of 5. And so we end up with 2 natural log 5 divided by natural log 4 minus natural log 5. And that's equal to x. And so this is an exact value for the solution of this equation. Now, before we move on, it's worth noting that there's several other things that we could have done here in order to find a solution to this equation. One thing is, at the very beginning, instead of taking the natural log, we could have taken the common log, base 10. And if we would have done that, everywhere in this problem where we have a natural log written, we would then have a common log, and we would end up with 2 common log 5 divided by common log 4 minus common log 5. This would be the same number, even though it uses a different logarithm. We could also use any logarithm, log base 3, log base 12, or whatever other base our heart desired, and that would carry through this entire calculation. The benefit of using common log or natural log is that we can use a calculator to approximate these solutions if that were important. Another thing that we could do to tidy up this equation if one wanted to is we could use log properties to simplify the numerator and denominator of this fraction. For example, in the numerator, we have 2 natural log of 5, and so the power rule says that we can bring a coefficient 2 inside the logarithm, and this would be, the numerator would become the natural log of 5 squared, or 25. In the denominator, we have the natural log of 4 minus the natural log of 5, and if we wanted to, we could use the quotient rule to write that as the natural log of 4/5. And so another way of writing this number x would be as the natural log of 25 divided by the natural log of 4/5. Neither of these answers are really in a better form than others. It's really just a matter of personal preference. If you'd like an additional practice problem like this one, try solving 2 to the x equals 3 to the x plus 1. The answer will appear in just a few seconds. Here are two equal versions of the solution, natural log 3 over natural log 2 minus natural log 3, or natural log 3 over natural log of 2/3. Of course, common log could be substituted everywhere here, and we would get two more solutions. And there are likely other formulations, but these are the two that I was able to come up with pretty quickly based on the previous example. For another example, let's solve the equation 100 equals 20 e to the 2t. In order to solve this, we first need to get an exponential alone on each side. And on the right side right now, we have an exponential e to the 2t multiplied by 20. So the first thing that we're going to do here is divide both sides of this equation by 20. When we do that, on the left, we get 5, which is 100 divided by 20. And on the right, we get e to the 2t. The 20 will cancel. At this point, we can take the natural log of both sides. And unlike the previous examples, taking natural log here makes the most sense because on the right side, we have an exponential base e, and the natural log of e to a power is just that power. In other words, what we have here is the natural log of 5 equaling 2t. The natural log and the e as the base of the exponential cancel out as they're inverses of each other. So we get natural log of 5 equals 2t, and we divide by 2 to get t equals natural log of 5 divided by 2. And this is our solution to this equation. If you want to practice with a similar problem, try to solve 3 times e to the 0.5t equals 11. The answer will appear in a few seconds. This is one version of the solution. If you had a different number but involving 2, 11, and 3, see if you can use log properties to manipulate it into this particular form. If so, then you have the correct solution. In this example, let's solve 4 times e to the 2x plus 5 equals 12. This is pretty similar to the previous example. We're first going to isolate the exponential term on the left side and then take natural log. To isolate the exponential term, we'll start by subtracting 5 from both sides and get 4e to the 2x equals 7. And we'll then divide both sides by 4 to get e to the 2x equals the fraction 7/4. At this point, we can take natural log of both sides. And we know that on the left side, that's going to simplify quite nicely. In fact, it's going to just equal to 2x, the exponent, because the natural log and e to the x will cancel out. And that'll equal, of course, natural log of 7 to the 7/4. And to solve for x here, we just divide by 2. So we get natural log of 7/4 all over 2. Of course, if we prefer, we could write this as 1/2 times the natural log of 7/4. It's the same thing. Just depends on how you want to format that answer. Both are relatively the same form. And so this is our solution to this particular equation. If you want an additional practice problem like this one, try solving 3 plus e to the 2t equals 7e to the 2t. As a suggestion here, the first thing that you might want to do is subtract e to the 2t from both sides. The answer will appear in a few seconds. In our last example here, we're going to solve e to the 2x minus e to the x equals 56. Notice that this equation is a little bit different than the ones we've looked at previously, as we have two exponential terms on one side and a constant on the other. We're not going to be able to isolate an exponential term, and we're not going to be able to set them equal to each other. And so here, what we're going to do is actually factor this equation. In order to do that, we need to move all the terms to one side. So the first thing that we'll do is subtract 56 from both sides. to obtain the equation e to the 2x minus e to the x minus 56 equals 0. Right, this equation is what is called being quadratic in form. It looks somewhat like a quadratic function, but it's not, because we're not raising x to the second and first power, we're raising e to the x. We can make it a little bit more natural as a quadratic if we make a substitution. For example, here we could let w be e to the x. And if we do that, then w squared would simply be e to the x squared, and e to the x squared can be thought of as e to the 2x power. And so making these substitutions, we see that e to the 2x is w squared. We're going to subtract from that e to the x, which is w, minus 56. That's all equal to 0. And now this is a standard quadratic equation. We can solve it in a variety of ways. The easiest algebraically is probably to factor this equation. This equation, w squared minus w minus 56, is going to factor as w minus 8 times w plus 7. Negative 8 and plus 7 will give us the negative w, and negative 8 times 7 will be the negative 56. And so here, when we have a product equaling 0, we can set each of these factors equal to 0 and solve. And we get two potential solutions, w equals 8 and w equals negative 7. Now it's important to remember that these are not the solutions of the actual equation. These are values of w. We want values of x. But of course, we can go back to x at any time using our substitution. So now we're going to replace w with e to the x. And so we get two equations here, e to the x equals 8 and e to the x equals negative 7. Each of these are exponential functions, and we can solve them using logarithms. E to the x equals 8. We can take a natural log of both sides. On the left side, natural log of e to the x is simply x. And so we get a solution of natural log of 8. If we try to do the same thing with the other equation, we take the natural log of e to the x equals natural log of 7, we see that something goes wrong. A natural log of negative 7 is not defined. Recall that logarithms are only defined for positive values. And so here we have the natural log of a negative, which is an undefined number. So e to the x equals negative 7 has no solution. This actually we could have realized without taking that logarithms, as e to the x is always going to be a positive number. And so a positive number will never equal negative 7 for any value of x. And so we could actually have seen right away that there's no solution to this particular equation. Therefore, the only solution to our original equation, e to the 2x minus e to the x equals 56, is the natural log of 8. If you'd like to practice a problem similar to this, try to solve the equation e to the 2x equals e to the x plus 2. The answer will appear in a few seconds.